So the very first question, how many solutions does this equation have? What do you think? 3. That is correct. How do you know? The degree. Now, graph it. Type it in the graphing calculator. Please graph it. Where's the 3 solutions? What? No, solutions are always on the x-axis. So where are they? I only see 1. Where could they be? What? Oh, well, yeah. I guess we could maybe have an x-intercept at 11. And I'm not going to see it because my graph only goes to 10. So we can zoom out, yeah. All right, so I'm going to go zoom out, enter. It's not there. Zoom out, enter. What'd you say? Oh, you're saying there could be a multiplicity? All right, well, let me zoom into that spot to see, because if there's a multiplicity, it won't go straight through it. If there's like, well, if there's a multiplicity of 2, what would the graph do? It'll bounce, so it won't go through it at all. So this is finding an odd multiplicity, and we have to have 3 solutions, so it can't be 5 of them. Our only option would be that there's 3 of them right there. So let me zoom in right there. I'm going to hit zoom, and then 2, and then I'm going to zoom in right around that spot. So I'll take this little cursor and go over there and enter. It doesn't look cubic. Let's try it again. No, it doesn't look cubic. I have an idea. Let's take out the one solution that I can see. What do you think it's at? What solution is it? The one that it crosses through. -3. You can look on your table to see it says -3, 0. So let's take out that one that we can see using synthetic division. So that one is a 0. And then when I rewrite what's left over with the x's back in it, and I put the x's back in it, I now have x squared plus no x's plus 16 equals 0. So that's quadratic. I can solve it by square roots, factoring, quadratic formula, something. What method do you think I should use to solve this one? Like square roots, move the 16 over. So the x squared equals -16. What do we do when we square root both sides? Plus or minus. We get x equals plus minus square root of negative? I feel like we've seen that before. 4i. So now explain to me why we couldn't see the other 2 x-intercepts. Because they're imaginary. So there are 3 solutions. 2 of them you can't see on the graph because they're imaginary. So you cannot rely 100% on my graphing calculator to find all the these. You can rely on the calculator to find some of your answers. And you should know how many answers. But you're going to have to do some math to find some of them. All right, the next question it says, how many zeros does the function have? Is that different than how many solutions? It's a tiny little bit different. This is a different word. How are the equations set up differently? How are the equations different from A to B? Yeah, so question B has an f of x, where the the y spot has an f of x. Up here, question A, we've already plugged in the 0. So this is just an equation that we solve for. Down here, we're talking about graphically the when y is 0. So down here, we would have to make this 0 first. I didn't do it. We'd have to make that 0 first. If you're putting in the 0, they're called zeros. But you don't actually have to find them. It's just asking how many there are. So how many? How many zeros? 4. I'm just asking how many. This one we were talking about how they can be imaginary, but we're not actually finding them yet. All right, there's 2 student practices. Can you answer those? Make sure you have the correct vocabulary word, whether it be solutions or zeros. So don't just put 3. We're working on vocabulary. Don't just put 3. Put either solutions or zeros. You need to go back so you can see what I named them in the first 2. Look at what I named them. What's it called? What's it called if you are putting the 0 in? What am I calling the answers if you're putting the 0 in? Am I not making sense? Here's the 2 options for vocabulary word. If I'm putting the 0 in, if it's not already there, and I'm putting the 0 in, what are you calling it? A 0. Otherwise, it's just a solution. But if you put the 0 in to solve, that's when you call it a 0. So how do we do? How many on this one? 4 what? Solutions. And then how many on this one? 3 zeros. Okay, next page. Finding all the zeros. Step 1. Graph on the calculator. Do it. Oh, I forgot to say something. While you're graphing on the calculator, how many zeros or how many solutions, how many should I be getting? 5 zeros. Okay, we want to think about that first, just to make sure that our answers match up with the fact that we should have 5 when we're done. Zoom 6, because we were fooling around with the window. Oh. Yeah, if you need to hit Zoom 6 to fix your window, Zoom 6. So how many zeros are we thinking we see up there? What are you thinking? We can see 2. We can see 2. What do you think? 2? Somebody disagree? There should be 5. Question though. So I'm just gonna totally sketch that, so I don't have to keep going back and forth to the calculator. You guys have the calculator in front of you. I'm just sketching kind of what it looks like, so we're gonna forget what it looks like. Okay. So it kind of looks like this. kind of what it looks like. Okay. So this says graph in the calculator. Find any zeros. Look for repeated solutions from the behavior at the graph of those solutions, at those zeros. Look for repeated solutions. What does it tell you? Right here, when the graph comes up to the x-axis and then bumps down, what does that tell you? Does that tell you, Bruno? There's a multiplicity right here. We have a multiplicity. It could be 2 or it could be 4. It could be even because it goes up and then comes back down. Odds would pass through. So I know there's an even amount. Could it be 6? Could it be 6 of them? How many solutions do I have total? So I know there's not 6 of them right here. There could be 2 of them or there could be 4 of them. And then there's only 1 here. So what we're going to do is we're going to figure out what those numbers are probably are. What do you think this negative number is? What do you think it is? Negative 2? And then what about this number over here?
Negative 1 or 2. Positive 2.
So it's a 2 and then a negative 1.
Yeah.
I'm only looking at a sketch graph. You guys have the calculator in front of you. You need to help me out. Okay, so I'm thinking negative 1 is happening twice. So let's, in the next section, factor out the ones that we found and see what we have left. So we're going to use synthetic division. Before you go too far, did you copy the exact same coefficients that I copied? I'll let you forget something. If you do not practice this, you will not be able to all of a sudden come up with this on your own. It's not going to happen. Don't write the equation up. Okay, so I factored out negative 1, and it was a 0, but we were thinking that there were at least 2 at negative 1. So I'm going to factor out another negative 1 now from my quotient. Yep, there was another one. And we were also thinking that at 2, we pass through at 2 also. So I'll go ahead and take that out. The original question had 5 zeros. I've taken 3 of them out. So I have 2 left. When you get to the point where you have 2 left, it is now quadratic, and you should write it as an equation. Once you get to quadratic, you should write it as an equation. So we took 3 zeros out of the 5. That leaves you with 2 left. When you get to 2 left, write it as an equation. If you are falling asleep, you are more than welcome to stand. So my next step says solve for the remaining zeros using quadratic formula, square roots, complete the square. It doesn't say factoring, but you could do right factoring on occasion. When I have just an x squared and then a number, I like to do by square roots. I think it's easy by square roots. So I'll do x squared equals negative 4. So x equals plus minus square root of negative 4. x equals plus minus 2. So what kind of answers, what kind of zeros are our last two? They are imaginary. That's why we didn't see all of them on the graph. We could see 3 of them on the graph. We could see the repeated one, the one with multiplicity, and we could see the one by itself, but we couldn't see the imaginary one. So then step 4 says to write our zeros, or write your solutions. That's how I know there's more than one. If it goes straight through, it'll be 1. So it'll be like a 1. Okay? It says student practice, but we're still going to kind of work together. Make sure we got it. What should be step 1? How many solutions should this have? Okay, so we're going to think about that, and then what should we do? Yeah, graph it. So go ahead and put that in your calculator, graph it. And we're looking carefully to see how many we think there are at each 0 that we can see at each x-intercept. But I don't know about you, especially if you have the older calculators, it's hard to tell. Can we change something on our calculators so we can see what's going on? Over here a little bit better. Could zoom over there. We zoom in. We have to put that little hair over there and hit enter. It's still kind of hard to see a little bit. I mean, I can see now, but it's still a little bit hard to see. Oh, I would have been too far now. Can you tell what's happening at that 0? Can you see what's happening there? There's a multiplicity. Another place we can look is on our table. Look on your table. Every place that y is a 0, that is a 0. So we can see that at -3 it's 0 and at -2 it's 0. So let's take one of those out. I'll just do -3. It comes first. Let's take it out. And we start with 3 zeros. The degree is 3, and we took one out. That leaves us with 2 zeros left. If you have 2 zeros left, you should write the equation. If you have 2 zeros left, you should write the equation. And then we can solve it by factoring, by quadratic formula, by complete the square. Maybe square roots, but not for this one. This one does factor though. So I was able to factor in and get x plus 2 quantity squared. So that tells us that we do have another 0 at -2, which you could tell on your table in the graph. But what's the squared tell me? There's a multiplicity of 2, and that's why bounces off the graph instead of passing through it. So our zeros are going to be -3 and -2. Where -2 has that multiplicity, makes 3 total 0. So I'm going to stop talking, I'm going to pause the recording, and there is another student practice. I want you to go through the steps, and if you get stuck or you figure out what to do, ask some questions. And we'll go over it after that, and then we'll take a break. So we have 5 zeros to find. When you guys choose your first 0, it can be a different one than I chose. It can be a different one. We just eventually have to take out all the same ones. But it's okay if you started with 1 where I started with -1. And then according to our graph, it looks like there's a multiplicity at 1, so I'm going to try another 1. So I took out the 3 zeros that I could see. From there, once I have 5 zeros and I've taken 3 of them out, is this empty? That door next to you. See something there? There should be something there. No. There should be something there. No, the door. Keep looking. They're in there. They're there. Okay. All right, once I've taken all of my zeros out, the 3 of them, then I have 2 left, so that means write a quadratic. And then from here, I'm going to try to factor it. That's my favorite. Notice fast if it's factorable, but I know some of you already tried to factor it. And unfortunately, this one doesn't factor. So if it can't factor, then what do we have to do? You can either do complete the square, or you can do quadratic formula. I prefer quadratic formula, and we get this thing with sum. You ready? I'm going to write the formula down. You ready? Stay with me. X equals opposite. I don't know. Sorry. X equals opposite B. Did we forget it? No. Oh, so you're just making me have a solo for everything? Plus or minus square root B squared minus 4AC all over 2A. X equals opposite B plus or minus square root B squared minus 4AC all over 2A. You have to remember that on your own. If you are too cool to sing it, then I guess you won't remember. So then we're going to plug in our A, B, and C. X equals opposite of -2. So 2 plus or minus square root 4 minus 4 times 1 times 4 all over 2A. When we simplify it, we get 2 plus or minus square root of -12 all over 2. So as soon as I write that, what does that tell me about my other two solutions? They're imaginary, you can't see them. Now we just have to simplify and find what they are. We just need to simplify it. So the square root of -12, Let's simplify that first. We'll separate out the square root of 12 and the square root of negative 1. And what's the square root of negative 1? I. And then square root of 12 actually simplifies further to square root of 4 and square root of 3. Square root of 4 is 2. Square root of 3. So my next simplified step looks like 2 plus or minus 2i square root 3 all over 2. Is that simplified all the way? It is not. Because in the numerator, I can factor out, I can undistribute a 2 from both of those terms. So I can do 2 parenthesis 1 plus or minus I radical 3 over 2. And what happens to those 2's? So what were our solutions? We had plus and minus 1, and then we have 1 plus or minus I radical 3 for all of our zeros. But why is there only 4 sitting there? Because the 1 had a multiplicity of 2. So there's really 5 there. We just can't tell by looking at them. We have to go through all of our work to know that. Okay, let's stretch our legs. I got a different game to play today, but it is not a walking game, so. Okay, so this is called the complex conjugate theorem. On Friday, it was called the irrational conjugate theorem. These two theorems from Friday and today are completely related. So the work is going to be very similar. So when we have complex conjugates, or if we have irrational conjugates, this was from Friday, the irrational conjugates, we will have something like, for the complex conjugates, we'll have some number plus an imaginary number, and then the conjugate of that would be that same number minus the imaginary number. Those are conjugates. When we have the same first and last terms, but one is plus and one is minus. And then, just as a reminder, irrational conjugates would be something like a plus radical b and a minus, that was messy, square root of b, where we have 1 plus and 1 minus. That one has radicals in it. This one has imaginary numbers, but imaginary numbers are square roots. They're square roots of -1. So these are basically the same thing. And what you're going to have is, you're going to have to write the polynomial function f of least degree that has rational coefficients, the leading coefficient of 1. And then here's the most important part. The zeros are 2 and 3 plus I. So I'm going to go through what I taught on Friday. We're going to first write what x can equal. X can equal 2, and x can equal 3 plus I. And then you have to use the complex conjugate theorem that says if you have a radical, they come in pairs. And I is a radical. So it has to have its conjugate there. The imaginary numbers, never by themselves. Always pairs. Always pairs. So I have to have a third one. What will my third one be? 3 minus I, the conjugate of 3 plus I. So that's our first step. Do you remember what our next step is? We're going to make each of those say equals 0. So I'll move the factors over. X minus 2 equals 0. X minus 3 minus I equals 0. And x minus 3 plus I equals 0. So I moved it over. Now, once we have them all equal to 0, we can write them as factors of a polynomial that equals 0. Now once you do that, what did I tell you to do next? On Friday. So we're going to multiply it all back together, and it doesn't look like something that you want to do, but you do want to multiply the two ugly ones together first. It will make it easier in the long run. These are conjugates, and because they're conjugates, the imaginary numbers will cancel out if you've done it correctly. So what we're going to do is we're going to multiply, and while I do it up here, I'm going to color code each step so you can follow it and see if you're making any mistakes. You can follow my work. So I'm going to first distribute x to each term. So I'll have x squared, and I'll have minus 3x, and we'll have xi, or ix, however you want to say it. It's fine. Then I'm going to distribute the negative 3 to each term. So I'll have negative 3x, then I'll have negative 3 times negative 3, which is positive 9. I'll have negative 3 times I, so minus 3i. Then I will distribute the negative I to each of these terms. So I'll have a negative xi. I'll have a negative times negative positive 3i. And then I'll have a negative times positive I squared. Okay. Now because we are multiplying conjugates, all of the terms with the i's should cancel out. We should have no more i's. Let's see. The xi will cancel out with the minus xi. The negative 3i cancels out with the positive 3i. But I still have an I squared. Almost. So that we did in the last chapter. I squared is equal to negative 1. So where I have negative I squared, that's the same thing as having negative 1, which is the same thing as having plus 1. So I don't have any more i's. I will combine the rest of my like terms. I have an x squared minus 6x, and then I have this plus 9 and that plus 1, so plus 10. And that looks a lot nicer than it did before. But we still have that x minus 2 out front to bring down. And then we will distribute again. So this time I'm going to multiply x times everything. When you multiply 1x by everything, it's really easy because you just change the exponent. Oops, but I didn't. And then I'll multiply my negative 2 times everything. Just watch your signs. And we'll add up and combine our like term. And I'll write in front of it f of x equals. So this should be exactly like you did last Friday, except for it's an imaginary number instead of a square root. When you're ready to go on, turn the page. And what I want you to do is write what x equals for numbers 5, 6, and 7. Just write like x equals the very first step that I did for this one. I'm going to scroll it back up. Do this very first step where I said x equals 2, x plus equals 3 plus x. Do that for all three of those. We're not going to multiply out all three of those. Just do it for that all three of those. See if you can write what x equals for all three of those. So is it always only what they give you? Is it just what they give you? Or did we just talk about when you have to add more? Who comes in pairs? Who comes in pairs? Square roots and imaginaries. They come in pairs. So if you see either square roots or imaginaries, you got to add extras in. So my very first one, I should have x equals 1, negative 1, sorry. X equals negative 1, x equals 4i, and x equals negative 4i. Conjugate. Whatever the comma is. And a lot of you are looking at number 6 incorrect. Number 6, they've given you 2 zeros. Look where the comma is. So the first 0 would be at x equals what? 3. The next 0 is x equals 1 plus I radical 5. That whole thing. And does that need a conjugate? So my third 0 would be at x equals 1 minus I radical 5. And we have a number 7 to try also. The first one is going to be x equals square root 2. What's my next one going to be? Okay, I hear a few different answers coming out. Another one of mine is x equals 1 minus 3i. That's another one. But I'm missing one y. So radical. So I need its conjugate. I also need x equals negative radical 2. And what about this one? Do I need a conjugate? So I need x equals 1 plus 3i. So what I want you to do is you can choose either 6 or 7, depending on if you want a challenge or not so much. 6 or 7. Do you know which one's more challenging? Okay, 7's more challenging. You can try either of them. Try to work it out. Try to multiply everything together. 6 or 7. Okay? Try one of those. And that'll be the last example we do today. So a few people were asking me about this last term. When we multiply I radical 5 times I radical 5, you get a negative I squared, and then you get a 5, and it's all multiplied together. And remember, I squared is the same thing as negative 1. So we multiply a negative times a 5. This whole term becomes plus 5. which I add to plus 1. So I get x squared minus 2x plus 6 after I cancel out all those 5s. And then I bring down my x minus 3 and I finish. Question? Natalie, you're just talking to yourself. Let me know, because I want to help. That would be my ghost. It does whatever it wants with the board all the time.
Square root of 2 times square root of 2 is.
So this was fine, but then I don't remember. Okay, I gave you your assignment. Okay. I gave you your assignment. You have like 12 minutes to start it. That's good time. Yeah. Square root of 5 times square root of 5. Square root of 25. Oh, you have that. Yeah, I think you wrote something extra that's not. Let me just stop this video and then I'll look.